Hello Internet, and welcome to this video. Boy, have I got a tutorial for you today. If you are subscribed to my channel, you may have seen the video that I recently put up showing a little game test that I did called Find the Secrets. And basically the game was a test to create sort of a strange psychedelic mind-twisting effect where if you look away from a certain area for 2 seconds and then you turn back, everything could have changed and you will not have noticed until you turned around or until you looked in a certain direction. I am going to show you how to do that effect. I kind of called it unofficially the antechamber effect because of the game Antechamber, but I guess I'm going to call it something like seamless teleporting officially, because that's kind of what the idea is. So first I'll show you how to do the actual effect, and the theory of how to do it is pretty simple, but there's a little bit of Python involved, but fear not, it's not incredibly complicated. So what I have here is just a simple little scene setup. You will want to have a few things. First, make sure you're on Blender Game for the game mode. Second thing, under shading over here, make sure you're on Glsl shading mode, and you can also do that by going into your properties panel down here, hitting the render button if it works. There we go. And down here under shading, go ahead and hit Glsl. The other thing I hit Alt-Z to go into textured mode, because if you play the game in solid mode, everything looks like this. So yeah, you want to make sure you're in textured mode for that, so then you actually are able to get the game. Now I have a little character here set up already. I have simple controls. I have left, right, and moving and whatnot, and also a mouse look, which you can see if I go into the camera here. So I have a little character moving around. I have another tutorial up on how to do the mouse look in a simple way, so you can check that out if you want to. The character controls are basically just keys hooked up to motion actuators. Alright, so let's get started on the actual effect. Now, the effect is based upon the camera having a radar sensor on it and sensing a certain object, which is invisible or behind a wall, or something like that. So, in order to do this, we need the object first. So I'm going to go ahead and just keep it simple. Add a cube. I'll put it over here. I'll call this, well, test cube. Doesn't really matter. And I'll give it a game property. I'll give it a boolean, call it sense, and set it to true. So now we've got a cube with a boolean sense, and now I'm going to add 3 more properties, all of them floats. Call one x, call one y, and call one z. Now, here's what's going to happen. In general, we're going to have a radar sensor on the camera. When the player moves close to the cube, the radar sensor is going to hit the cube, and then it's going to get the information from the cube about where you want the player to be sent. Aha! So the scene is not actually changing around you. You're actually teleporting to another area. So let's see, how much do we want our character to teleport here? For the purposes of the demonstration, I'll have him teleport 5 up on Z, minus 10 on Y, and maybe 2 on X. How about that? Alright, cool. So we've got that. Now we're going to need to add a radar sensor to our camera. So add sensor radar. I'm going to look for the property sense, which is the same property that we added to our cube before, on the negative Z axis, so the radar cone will be pointing forwards on the camera, because that's how the camera's axes work. Give it an angle of 30 degrees, you can always change this stuff, and a distance of 5. Again, you can change that to suit your need. I'll hook this up to a Python controller, and in the Python blot, I'm going to make a new script here, call it detect.py, and just put that in here. Right now it's doing nothing, and if we run the game, looks like nothing's happening. However, if we go down here in our properties, in our render tab here, and we go all the way down to display, and we turn on physics visualizations, we will see, if we turn this on, we have a giant radar cone attached to our camera, and you'll notice that it's looking wherever the camera is looking. You can see this from the camera's point of view as well. we've got that circle here. Radar. Beep boop. Alright, turn that off. So that's basically where how that's going to work. Now, if we come over here, first to start off with the script, we have to import BGE, the Blender Game Engine Dictionary, define a main, and all the way down here, we have to run the main. So, tap that. Let's see. So first we want to get the controller and the object that this script is attached to. So we'll do const equals bge.logic.get ret apparently current controller. Alright, good. So now we have const, and now we'll say the owner of this controller is equal to the const.owner. Alright, perfect. Now we have the camera. Then what we want to do is get the sensor that's attached to this script. So we have the sensor attached here, and it's called a radar. So we'll call this, make sure everything is lined up perfectly. Indentations in Python can be quite the shifty business. We'll call it rad, is equal to const.sensors and square brackets, and inside the brackets we put quotation marks and the name of your sensor. So that's, in this case, it's radar, so put radar. The radar sensor, when it hits this box, is going to send a signal to the Python script, and then we want to get the information from the box. However, there's no real easy way to just get exactly what the radar is hitting, because the radar returns a list of objects that can be hit. Kind of, I could be wrong entirely about this. I could be going about this in a really convoluted way, but this is the way that I got it to work. So I'll show you this way, and if you have a better way, by all means, feel free to do it that way. Alright, so we're going to define a new method up on top here, and we'll call it get nearest objects, and we will have a master and objects, which will be a list. So we'll define nearest object. There we go. Nearest object is none, so null basically, and min distance is also none. So now we're just going to basically run through objects, which is our list. So for O in objects, we want to set, we want to get the distance to that object. So dist equals master dot get distance to O, which is the object in our list, and then we'll say if the min distance there we go, is either nothing or it is or the distance is less than the minimum distance, in which case we will change the nearest object to O and the minimum distance to the distance that we just found. And after all of this, after the for loop has completely gone through and found us our nearest object, we will return nearest object. Alright, so that should be our get nearest objects method. Now the reason we need this is because, let's say you have multiple cubes all throughout your scene, and some of them have different distances, different distance properties here, which is perfectly acceptable. We want to be able to get the right one. So we're going to say, we'll call it the sensed object. So sense object is equal to, and we'll call our method here get nearest object, function, sorry, I'm thinking in different languages, get nearest object, and we will pass it. The master is going to be this, basically, so own, and we'll give it the list of objects that the radar sensor gets, which is, by definition, rad, a radar sensor, dot hit objects list. So basically, since our sense object then is going to be the nearest object out of all the list of objects that the radar can hit. So that's cool. Now we want to get the scene. Scene equals bge.logic.get current scene. Simple enough. Now we want to get the player. Now I've named the player object here player. Very descriptive, I know. So we'll call a variable called player equals scene.objects, square brackets, quotation marks on the inside, player name. Alright, now we have a little bit more stuff. Not too much more to go on. However, one thing I found with this sensor is a little bit weird, is that it tends to activate twice, and I'm not 100% sure why that is. It could be a very simple fix, but the way I found to solve this problem, and it could also be kind of a mechanic for the game as well, is that I put a timer and made sure that the Python script can really only activate once at a time. So I'll add a property to our camera here, make it a timer, call it sensor timer, start at 0, and we'll say if, big if statement here, so if own sensor timer, and so that's the property that we just made, is greater than 0.5, so if the sensor timer, if it's been 5 seconds since the last teleport, half a second, sorry, 0.5 seconds since the last teleport, and sense object is not equal to none, just in case we have some weird stuff with the distances going on, and sense object, the property on sense object sense is equal to true. So remember how we set the property on here, which is our sense property, to a boolean and set it true? Well, you could actually start this off as false maybe, and then have something else turn it into true so that you can only teleport if certain condition is met or something like that. Just adding some more flexibility. So add the colon there. Now what we want to do is actually do the teleportation of the player. So player dot world position is equal to, and here's a big long statement. It's a vector with 3 components. First is x, second is y, third is z, and we want to add the x, y, and z that we have on the cube here. So first we're going to get the player, square brackets by the way, player dot world position 0 to start off with, plus, and then we have the sense object, the property and the sense object of x that we called x before. Now we put a comma, turn on, yeah, okay, I have line wrapping turned on here. In the bottom, these 3 buttons here. The middle one is line wrapping so that I can see everything and it doesn't go off the screen. And now I'm just going to copy and paste this for the y and z because I'm lazy and I don't want to write so many things. So for the second one now, we're going to turn a 0 into a 1 because it's the second component. Turn the x into a y. For the third one, turn the 0 into a 2 because it's the third component. And turn the x into a z. Now, we're almost done, but the last thing we have to do is reset the timer that's on the... Man, my computer is being slow right now. Alright, so own sensor timer is equal to 0. Alright. So this should work. I tested this before, but who knows, it might break. So, this is true. Oh, yes. One last thing that you have to make sure is that under the object, the physics tab here for your teleportation cube, make sure it's an actor, because if it's not an actor, the radar sensor is not going to be able to pick it up. Alright, so I'm just going to run this from third person view here and just press forward, and nothing happened. So I'm pretty sure I got an error somewhere. I'm going to toggle the system console. Here we go, we have an error. Alright, let's see. Camera controller has no attribute hit objects list. That's because I spelled it wrong. There is no attribute like that. It's not hit objects list, it's hit object list. Alright, let's try this again. Go forward. And more errors. Alright, where did my thing go? Here we go. In nearest object is not defined. Nearest object, because I spelled it with a lowercase o instead of an uppercase o. Oh, there we go. Alright, did you see that? Perfect. Okay. So I'll back up a little bit here. Press P, walk forward. There we go. Alright. So, boom. We'll go into first person view for that. So here we go. We have this going on. And boom. There we go. We're in a different area. Yay! Alright, it works. So, those are the mechanics of it, basically. And in terms of technical stuff, that's pretty much all you need to know. I know, there are going to be some people who are going to say, wow, you could do this so much better. And you're probably right. Because I threw this together quickly, but hey, it's a test, it's an experimentation process, and if you want to know how to start off with this is how you do it. Alright, so now what I'm going to do is just do a quick little demonstration of how you can get the teleportation effect to actually kind of look convincing in a way. So I'm going to get rid of the plane here, and the theory behind this is to basically have two areas where one section of those two areas looks identical from a certain angle. So I'll tab in here, turn scale by 2, oh, not 20, scale by 2, yeah, okay, scale by 2. I will hit T, move this over here, and shading UVs, I will flip the direction of the normals so they're facing the inside, and scale it along Y by 8, scale it on Y by 4 maybe. There we go. Alright, so now if I hit 0, I hit P, there's going to be no light in here. Alright, the lights are a very important thing. So, just to demonstrate, I'll take this light. I will turn off specular reflection because that seems to cause problems. I'll just hit Alt-G so it goes to the middle there. I'll go to my side view and GY for 6. Maybe I'll put the light at 6. And now here's the thing about the lights. You don't want the lights to spill everywhere, so you want to have a matched kind of distance on these things. 30 is a little bit too much. I found 12 in my last test to be pretty good. So I'll put a distance of 12 there. Hit 0, Alt-Z to go into texture mode, and P. Alright, so now we've got a cool looking hallway here. Ooh, spooky! Alright, and I'll put another light. I'll Shift D, Y, negative 12, just I put it on 6 last time. So you'll notice how, from the side view, the light from one side here will not reach the other edge of the hallway here. That's very important in order to make kind of that seamless look. So right now we're in this hallway, which looks the same from both directions. Nothing too special. Well, now we can take this along with the lights actually, and Shift D, duplicate it along the Z by 20. There we go. Just for simplicity's sake. And since we moved it on Z by 20, we go to our cube here, and we'll delete the X and Y. We'll make those both 0, and make the Z component here 20. So when our player runs into the cube here, well, when the radar detects the cube, it shoots our player up 20 units right into this thing that looks almost identical. Alright, so now in your top thing here, you're going to want to change something. But you're going to want to make sure that since this area down here is where the player is going to be looking, if we turn on the physics visualizations over here, we can see that the player has to be looking, like if you're looking backwards, it's not going to work until you turn around and boop, there we go, it works. So the player is going to basically be looking at this wall when the magic happens. So everything that the player can see from that particular angle cannot change. Alright, but that leaves us free reign with everything else. So, let's see, what can I do? I can extrude this by -12 maybe, I don't know, and loop cut it there, and extrude that, and extrude that, and duplicate some lights. Just making sure though that none of these lights interfere with that one area that we will be looking at when we teleport. Alright, so we've got a different area up here. You know what, just for fun, let's make one of these lights. Let's turn it blue. Alright, awesome. For science, right? Did that work? Yeah, it worked. Alright, perfect. So now if we go into our view mode here. Oh, we still got the physics visualizations on. Alright, turn those off. Alright, so we'll play the game. Nothing special going on here, right? And we're like, oh, I wonder what happened with this wall. Ready for it? Dun dun dun! Seamless! Alright, that worked perfectly. So there you go. That's how you do it. That's how you make that seamless teleportation effect. I really love it, honestly. I'm gonna try and work on some more game mechanics and stuff on it. One of the other tricks that I had in the game was an infinitely looping staircase, and that's like it's more simple with this technology now. We have the technology. It's more simple than it might initially seem. Basically, I created a segment of staircase, and if you got too low, it would teleport you up one section, like a repeating segment that went like that repeated 3 times. And if you got to the bottom section, it would teleport you up to the middle section, and if you got to the top section, it would teleport you down to the middle section. So no matter which direction you went, you would always be going in circles, but it would look like nothing changed, because everything, the staircase was segmented in such a way that it was identical on each level. Alright, so there you go. That's how to do the seamless teleportation effect. Man, gets me every time. Gets me every time. Yeah, so there we go. I hope you enjoyed the video, and I'll see you next time. Haha.